So let's start today's lecture. And one of the things is I really encourage you to start working on the project soon. The project is still a project. It's substantial, right? It's more than a homework. And since the communication over the internet is probably not going to be as efficient as just coming to office hours, it might take a little bit of more time if you encounter things you can resolve by yourself. So so I encourage everybody to start the project quickly. So here I'm just showing the project itself. For those who haven't started looking at it, please do, because essentially you have all the material to really finish it today. Basically, we are looking at like a soft material during reentry, like coming down from space. So going through vacuum and atmosphere in hypersonic speeds. So we are modeling the membrane, the soft object, as a membrane, but we are only considering a one-dimensional membrane. In reality, it'll be a two-dimensional object, but like for simplicity of this project, we'll treat it as one dimension. So the equations are outlined in equation 1. So this is really something very similar to the equation we have been discussing in finite elements. We have this second derivative in space, where in this case, y is the unknown. Y is the unknown shape of the membrane here. So and instead of a first order time derivative, you have a second order time derivative. And it is up to you to look into how we discretized, how we dealt with a first order time derivative, and think what's the best way to deal with the second time derivative. And you'll find out, if you understand how we deal with the first order time derivative, treating this is actually not too different from how we treated the first order time derivative. All right, so the various questions are, for example, in the beginning, we are going to be considering zero outside pressure, basically in vacuum. And we are going to figure out how the membrane is going to vibrate or reach equilibrium, right? Or not. So this is really the first question of asking you to discretize the differential equation using finite elements and figure out what kind of ordinary differential equations you get. All right, and the second is basically solve the equations. And the third question is now we consider there is atmosphere, and the outside pressure actually has to be described using a simplified fluid dynamics equation. So this is a equation called piston theory. So basically, in this case, derive the equations again using finite elements. Basically, the procedure has to go through, okay, you have the equations, you have to derive the weak form, and then how do you go from the weak form to the restricted space of the function, and then derive the matrices that comes out of the finite elements. And question 4 again is really to solve these equations that you derive in question 3 under several different conditions. So that's kind of the project. As you can see, you really have all the materials you need to do this project, to finish it from beginning to end. All right, any questions on the project? No? Yes? No? Okay.